So I mentioned this at the end of the last video, the idea of the word equivalent. What do we mean when we have two graphs that are equivalent? The definition, the formal definition, is when two graphs have the same vertices and they're connected in the same way, then we call them equivalent. So if you first glance at these two graphs, you might say, oh, those aren't equivalent, they don't look the same at all. But just picking on C, for example, C is connected to A, B, and D. And if I start over here, C is connected to A, B, and D. And you can run through every point and you'll find that these are equivalent. They are connected in the same way. So let's just practice that idea. That's what example 4 is about. It says drawing an equivalent graph. So we have this one graph that's given to us. So we've got a graph already with various vertices and connections and so on and so forth. And then we have the start of another graph. Now just pick on C, or pick on point E, for example. If I look at point E, it is only connected to A and C. If I look at E here, it is connected to A and it is connected to C. So I've already got vertices A, C, and E given. I need B and D, so B and D are missing. So I'm just going to put B down here. I'm going to put D up here and say, okay, let's see if we can make this work out. I'm going to get that extra circle out of the way just so it doesn't cause any confusion. And then what do we have? So E is connected to A and C, so we don't need to do anything with E. That's fine. If I look at point C, it's connected to E, which we've already got. We need to connect C to D, so C's got to go over here to D. And we got to connect C to B twice. So C to B, C to B. Okay, so that is taken care of. So now we've got E done, we've got C done, we've got B done, because B only connects to C and nothing else. We've got to fix A. So what do we have missing? A is connected to E, but not D. So now if we take A up to D, now we're good there. A is connected to only D and E and nothing else. And then the only thing left is D to double check, and D is supposed to be connected to C and A. And if I look at that, D is connected to C and A. So this graph that we've drawn is now equivalent to this graph. Even though the shapes don't look anywhere near the same, the graphs are considered equivalent. And it's important to point out that there are, in many cases, for many of these graphs, multiple correct answers that you could get when you're doing this on ALEKS. So your drawing that you do may not look anywhere like the drawing that I make, but they still, as long as they're equivalent, ALEKS will count it correct.